Though they're intimately connected to one another, machine learning doesn't get the rapt public attention being paid to artificial intelligence. Yet just about every aspect of our lives and livelihoods is influenced by machine learning, a type of AI that can be seen as the ultimate statistician. Machine learning, or ML, involves the development of computer programs that learn and adapt without following explicit instructions. It uses algorithms and statistical models to find patterns and relationships in data, analyze them, and identify trends or predict outcomes. Machine learning algorithms also classify information and even help generate new content and software code. For example, AI tools ChatGPT, DALL-E, and GitHub Copilot are fueled by ML. Here, we'll examine the basics of machine learning, as well as the benefits, challenges, strategies, and what else businesses need to know about it. For a deeper dive, explore our complete collection on all things machine learning by clicking the link above or in the description below. Machine learning has played a progressively central role in human society since its beginnings in the mid-20th century. Training machines to learn from data and improve their performance over time has enabled organizations to automate routine tasks previously done by humans and, in principle, free us up for more creative and strategic work. Machine learning's ability to extract patterns and insights from vast data sets has also become a competitive differentiator for companies in various industries. Take these real-world applications, for instance. ML-powered recommendation engines are used by e-commerce, social media, and news organizations to suggest products or content based on a customer's online behavior. Machine learning algorithms and machine vision are critical components of self-driving cars, helping them safely navigate the roads. In healthcare, machine learning is used to diagnose medical conditions and suggest treatment plans. And machine learning is essential in fraud detection, spam filtering, malware threat detection, predictive maintenance, business process automation, and other applications. Machine learning is often categorized by how an algorithm learns to become more accurate in its predictions. The four basic types of machine learning are supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. In supervised learning, data scientists supply algorithms with labeled training data and define the variables they want the algorithm to assess to make correlations. The input and output of the algorithm are specified. Supervised learning algorithms are used for tasks like binary classification that divides data into two categories, multi-class classification to choose between more than two types of answers, ensemble learning, which combines the predictions of multiple machine learning models to produce more accurate results, and regression modeling that predicts continuous values based on relationships within datasets. Most machine learning algorithms initially worked with supervised learning, but unsupervised approaches are becoming popular. Unsupervised learning algorithms don't require labeled data. They sift through unlabeled data and search for patterns that can be used to group data points into subsets. Unsupervised learning algorithms are used for clustering, which splits a data set into groups based on similarity, anomaly detection that identifies unusual data points in a data set, association rule mining to discover sets of items in a data set that frequently occur together, and dimensionality reduction that decreases the number of variables in a data set. Semi-supervised learning works by feeding a small amount of labeled training data into an algorithm. From this data, the algorithm learns the dimensions of the dataset, which it can then apply to new unlabeled data. The performance of algorithms typically improves when they train on labeled datasets, but labeling data can be time-consuming and expensive. This type of machine learning strikes a balance between the performance of supervised learning and the efficiency of unsupervised learning. Semi-supervised learning can be used in the following areas as examples: teaching algorithms to translate language based on less than a full dictionary of words, detecting cases of fraud when there are only a few positive examples, and learning from small sets of training data how to apply labels to larger data sets. Reinforcement learning works by programming an algorithm with a distinct goal and a prescribed set of rules for accomplishing that goal. The algorithm can be built to seek rewards for performing an action that helps achieve the goal and to avoid punishments for performing one that moves it farther from its goal. Reinforcement learning is often used in training robots on how to perform tasks, teaching AI bots to play video or strategy games, and helping companies solve complex resource allocation problems. But many machine learning algorithms and techniques aren't limited to just one form of learning. They're often adapted to multiple types, depending on the data set and the problem to be solved. Developing the right machine learning model to solve a business problem requires diligence, experimentation, and creativity. Here's a 7-step plan for building an effective model. Number 1, understand the business problem and define the success criteria. The goal is to convert knowledge of the problem and the project's objectives into a suitable problem definition for the machine learning model. Number 2, know and identify the data needs. Determine what data and how much of it is needed to build the model and whether the data is in shape to be ingested into the model. Number 3, collect and prepare the data for model training. Often, it's necessary to clean and label the data, replace incorrect or missing data, enhance and augment data, reduce data noise and remove ambiguity, anonymize personal data, and split the data into training, test, and validation sets. Number 4, determine the model's features and train it. The right machine learning algorithms and techniques are selected, hyperparameters that guide the training process are set and adjusted, and the model is trained, validated, and optimized. Number 5, evaluate the model's performance and establish benchmarks. This work encompasses confusion matrix calculations, key performance indicators, machine learning metrics, and model quality measurements to analyze performance and determine if the model can meet business goals. Number 6, deploy the model and monitor its performance in production. This step is known as operationalizing the model. After deployment, continuously monitor the model and iterate as needed to improve overall performance. And number 7, continuously refine and adjust the model. Even after the model is in production, the work continues. Business requirements, technology capabilities, and real-world data can change in unexpected ways, potentially giving rise to new demands that require modifications to the model. In addition to being widely applicable across industries, machine learning is integral to the business software that runs organizations. Here's a sampling of how various business disciplines and software tools use machine learning. Business intelligence and analytics. BI tools and predictive analytics software use machine learning algorithms to identify significant data points, patterns, and anomalies in large data sets. Customer relationship management. Key applications in CRM software include analyzing customer data to segment customers, predicting buying habits, making product recommendations, adjusting pricing, optimizing email campaigns, providing chatbot support, and detecting fraudulent transactions. Security and compliance. Advanced algorithms identify deviations in network behavior, which is crucial in detecting potential cyber attacks. Human resources. Machine learning models built into HR information systems streamline the hiring process by filtering through applications and identifying the best candidates for an open position. Supply chain management. Machine learning techniques optimize inventory levels, streamline logistics, improve supplier selection, and proactively address supply chain disruptions. And natural language processing. Machine learning models enable virtual assistants like Alexa, Google Assistant, and Siri to interpret and respond to human language. Machine learning is a powerful tool for solving problems, improving business operations, and automating tasks, but it comes with its share of challenges and pitfalls. Resources. Machine learning is a complex process that requires deep expertise and significant resources. Machine learning projects are typically led by high-paid data scientists and use expensive hardware and software. As a result, it costs a lot to develop, tune, and run ML models. Data volume. Training machine learning algorithms often needs large amounts of high-quality data to produce accurate results. Data analysis. The results can be difficult to understand, especially ones produced by complex algorithms like the neural networks used in deep learning, an advanced form of ML. And accuracy. Algorithms trained on datasets that exclude certain populations or contain errors can lead to biased, inaccurate models that, at best, fail, and at worst, are discriminatory. The massive amount of research by companies, universities, and governments around the globe makes machine learning a rapidly moving target. Breakthroughs in machine learning and AI as a whole seem to happen daily, rendering accepted practices obsolete almost as soon as they're accepted, and progressively blurring the boundaries between machine intelligence and human intellect. As the volume of data being generated continues to proliferate, machine learning will likely become even more vital to businesses. And the abundance of that data will also further strengthen ML's data-driven learning capabilities. Businesses and society at large will continue to encounter issues with bias, as well as trust, privacy, transparency, accountability, ethics, and machine learning's impact on people. But one certainty is that machine learning will continue to play a central role in organizations.